So 5.4 is called Developing and Using the Triangle Midsegment Theorem. So the first thing we're going to talk about is what is a midsegment. And you might even be able to figure it out from looking at the picture. So first let's look at x. Andrew, what do we know about x?
It's a midpoint.
Yes, good. How do you know that?
Because it's in the middle of P and Q.
What tells you that on your diagram?
Each side is congruent
Yes.
to each other.
Good. Okay, so each segment on either side, xq and xp, they are congruent to each other, which means that that is going to be a midpoint. Awesome. Now that also happens with y and with z. So this is a midpoint, and this is a midpoint. You can see from here, they label the midsegments for you. So your midsegments are xy, yz, and xz. Yeah, so you're basically just doing what? Well, you're just connecting all of your midpoints, okay? So you are going to connect all midpoints of your triangle with your segments. Okay, so then if you connect them all together, that's going to form your midsegment triangle. Bless you. Okay, your midsegments are formed from each pair of midpoints. So from x to y, y to z, x to z, those are your three pairs. So there are a couple of special things that we know about midsegments, and they are summed up in the theorem. Now there are a couple different things that we know when we have a midsegment. Okay, so the midsegment of a triangle is a couple things. So the first thing that it is, it's parallel to a side of the triangle. The second thing that we know is that its length is half the length of that side. Okay, and when it says that side, it means the side that it's parallel to. So let's look at the midsegment here. So our triangle, okay, your whole triangle is triangle ABC. Okay, one of the midsegments, and this one just has one of them drawn in, is from D to E. So D to E, those are both your midpoints. You can see that because they're labeled. BE is congruent to EC. AD is congruent to DB. Okay, so that means DE is your midsegment. So from the theorem, that means that DE is going to be parallel to one of the sides of the triangle. If you look at your triangle, why can't DE be parallel to AB?
Because it's going
Yeah, it's going into it, right? Aren't they intersecting? So by definition, it can't be parallel. The same thing happens on this side, right? So the only side it could possibly be parallel to would be what? Good. Now that is labeled for you over here, right? So you would know that it's going to be parallel. So that's one of the things that it tells you. The other thing it tells you is about the length. So whatever sides are parallel, that's what it applies to. So it's either DE is going to be half the length of AC, or you could also think of it as what? Let's say that you were given DE. How would you know what AC is?
Just draw a line straight down from B.
Well, how would you find out what it is? Like if DE was 5, what would AC be? 10. Yeah, how did you do it?
Double the line.
You doubled it, right? So you can go the opposite way. You can think of, oh, this is half half of AC, or you can think of AC is double what DE is. Okay, so either way you can think of it. So in our example, you're going to find each measure. Now, because of the picture, you can tell that B is a midpoint, F is a midpoint, and D is a midpoint because of these congruent markings on either side. Okay, so we can see that B, F, and D are midpoints. Okay, so if those are midpoints, then we have some mid-segments here. So we have the mid-segment BD, so from B to D, from D to F, and from B to F. So since these are all mid-segments, we know they are parallel to a side of triangle ACE, triangle ACE here. So we're going to mark off which side they are parallel to, because not only are we going to know that they're parallel, but then we also know that the mid-segment is going to be half the length of that side. So for BD, BD is going to be parallel to what side of the triangle? AE, good. And then I just marked these in different colors so you could see what went with what. So let's do another mid-segment. Besides BD, we have DF. DF is going to be parallel to what? AC, good. Okay, so it's this whole side here. And then the last one is going to be BF is parallel to CE, good. All right, now when we're trying to find BD for the first one, we know because this is a mid-segment, BD is equal to 1/2 the side it's parallel to. So BD is parallel to AE, so it's going to be half of that segment. Do we know what AE is? 17. So we can just do half of 17. What's half of 16? 8. So this is just going to be 8.5, 8.5. So that's going to be your length of BD. I'm actually going to add another question in here. Let's also do, we'll call this part C. Let's find AC. Okay, so AC is a side of the triangle. Okay, for BD, this was a mid-segment. This is a side of the triangle. So we know that AC is going to be compared to this length because they're parallel. What's their relationship? If this length is 6.2, AC is going to be, and then because their relationship is, how did you know it was 12.4? Yeah, it's doubled, right? Okay, so the length of AC is double the length of DF, so that means AC is equal to 12.4. Now, for the last part, you have to keep in mind what happens with parallel lines. And whenever you have parallel lines, what special angles are formed? Yes, and they're congruent if they are alternate interior angles. So if you're trying to find CBD, CBD is going to be congruent to, yes, because we know that these two lines are parallel, alternate interior angles are formed, and we know they are congruent. So the measure of CBD is going to be 26 degrees by the alternate interior angles theorem. And then just remember that when parallel lines are present, they are going to form alternate interior angles, same side interior, alternate exterior, and that should say corresponding. Alright, and then for 5.4, your homework section is here. And then on the back of your note sheet is just diagrams that go with your homework in case you wanted to write on them.